Hello, everyone. It's time for Catalog and Cocktails. It's your honest, no BS, non salesy conversation about enterprise data management with tasty beverages in hand. I'm Tim Gasper, longtime data nerd, product guy, customer guy at Data.World, joined by Juan.
Hey Tim, how are you doing? It's Wednesday, middle of the week, and you'll be. Well, we are pre-recording this. Honest, no BS. We're pre-recording, but you are watching this Wednesday in middle of the week, towards the end of the day, and probably listening on Thursday. And today we are super excited. This is again. I love. There's always some interesting stories with every guest that we have. Today, our guest is Vinoth Chandar, who is the creator of Apache Hudi, who's now the co-founder and CEO of Onehouse. Vinoth, how are you doing?
I'm doing good. Thanks for having me here, and good to see you after so many years.
Well, yeah. So interesting story around this. Well, Vinoth, first of all, like they did all the Apache Hudi stuff back when you were at Uber, but I think the story here is that I was Vinoth's TA, database TA, back in 2008, 9, 10.
Yeah, so back in UT Austin, and I think you can still find my project report online if that's interesting to you still. But yeah, I think and thanks for the on the class as well. So yeah, it's good to good to see you after such a long time.
Well, there we go. We got this is actually a pretty cool moment.
It's a small world, huh?
It is. That's true. The data world is small, and it goes back a long time, right? So,
Yeah.
anyway,
It's so exciting to see where you are on your journey, Vinoth. I think it's very exciting.
All right, yeah.
Well, let's. What are we drinking, or what do we like to drink the most, and what do we want to go toast for?
Well,
what's your favorite drink, or what are you drinking with toast?
Well, I mean, I know it's supposed to be catalogs and cocktails, but it's too early for a cocktail. So I'm still working. So I have like a cup of coffee, my favorite brew, and yeah, maybe I'll make do with this. So yeah, toast to maybe like open data and like all the things that are going on in the space, which is really exciting right now.
All right,
That's awesome.
Tim. How about you? What are you drinking? I think you are.
Well, it's not too early for me to have a little bit of a cocktail. Well, not really a cocktail. This is just a little bit of Johnny Walker Black, so nothing special here. Just a little something. What about you, Juan? What are you drinking?
Well, I'm actually enjoying. I mean, people who've been listening, I've been enjoying also sparkling waters. I have no affiliation with Waterloo, but I just love their stuff, and they have a new one, peach, which I love. But Johnny Walker Black on the rocks. That's something I always love. And let's cheers to like this open data, the formats we're going to talk about, and also just you never know who you're going to meet in life, and you're going to keep going, and then just things just paths cross unexpectedly. So cheers to that. Cheers,
All
everybody.
right. Cheers. Yeah.
All right. So our warm-up question today, because we're going to be talking about table formats and stuff. So this is a weird one. What's your favorite type of table?
Well, let me see. You're putting me on a spot here. A table that I can read and write on and read from. I guess like that kind of lines up with kind of whatever we stand for right now, which is we want to make sure we have like the most open table, if you will. The table's always not taken and open, not taken by any vendor, if you will. So yeah, that's the kind of table that I've grown to like over the last few years. An open table.
An open table. All right. I like that.
Always not taken by any vendor.
There you go.
Tim, how about you? What's your favorite type of table?
Well, my first thought to this question was immediately to go in a joke direction. I was like, well, I prefer an end table. I think that would be a great thing. I'm going to go in a different direction. I'll say no table at all. I loved walking around and pacing around and just having a whiteboard. And I was doing a little whiteboarding earlier today. So my favorite table is the lack of a table.
That's awesome.
Well, here my table. I like my table's a desk, and I really like the standing tables, the desks, so I can put it down. But I also like round tables, round table discussions. I love to sit down and actually have good discussions, and it's really cool when you're like with 3 or 4 people, you end up at a table and having that really meaningful conversations. So that's something which again tables enable that. So hopefully you have an open table, you can sit down and join a good conversation. And I think we're taking this metaphor a little too far.
I think this truly proves that intelligent people can small talk about mundane things for hours.
All right. Yes. Talk about table. What is a whole buzz around table formats and lakehouses and all this stuff? Take us away around this.
Yeah. Okay. So maybe I'll talk. I can talk about it at length and like kind of trace you to the entire history. But in summary, it's a result. All this buzz is a result of customers basically saying, "It's my data. Just leave it alone in my cloud storage bucket." And and hell, let me bring it to the next query engine or next cool new thing that comes on in the market to operate on the data. That's kind of like in a nutshell what's kind of going on, right? And if you the long form of this answer, we basically need to go back to maybe even like a decade or so, right? So we, as I mean, I don't have to like talk to this crowd over databases. So like databases, there are different layers. There's a storage layer. It's been it's like it's been pretty much closed, right, for a long time, and it was okay because you were operating in the world of relational databases where you were installing them on a specific hardware, right? It's not like you can easily share the data across with another, like an engine running on the same machine, right? But what happened as we went into the whole disaggregation of storage and compute was that there's value in that. There's value in like even if you look at the forgotten Hadoop era, if you will, right? There's a lot of these open file formats that came out, right? Where you have even CSV files, right? You don't have to go columnar and all that, like CSV, JSON. Like there is obviously Avro, like thrift files and like row-based files, and then you had Parquet, ORC, column-oriented storage. So there's really open file formats on top of horizontally scalable storage. And since you decouple the compute, you can now bring multiple engines. So back in the day at LinkedIn, we had Pig and Hive and MapReduce running on the same copy of Avro files. And Hive was the most advanced engine at that point in time, right? So now if you fast forward, you had like a...
Give me 1 second. Just I love history. I love this stuff. So to kind of ground things in time and history. So when do you start seeing the separation of storage? Will be like what years, and then what were like you talked about like Avro, thrift, and stuff. Like when do these things start happening? Like I think this is great progression, so people realize like the history.
Yeah, so this is the 2000s, right? So we sold databases one way for 3 decades, from the relational database like OLTP, your Oracles and the Sybases of the world, to then Teradata and the warehouses started to emerge. I think up till this point, it was like a closely knit, database, right? You had a OLTP, you had a specialized database for analytics called the warehouse, right? OLAP OLTP. So really all of this started when the social networking and all the like search and all these things, we started building recommendation systems and all of that. That's actually where that was the first big use cases for some system like Hadoop, right, or MapReduce. So that is the first point where 2010s, the story that I'm talking about is like 2010, right? So that's basically where you actually got the storage and compute separation done. Famously on the cloud warehouses, as cloud started to become like a lot of prominence in the 2010s, you saw BigQuery and Snowflake famously decouple compute and storage, right? But data lakes had kind of done that before that. Sadly, Redshift probably didn't do that right off the bat, right? So there's still a couple system, but both BigQuery and Snowflake did that, but on top of proprietary data formats, right? So that now brings us to where we are today. So tons and tons of companies have migrated from their on-prem data warehouses onto the cloud, onto one of these like kind of closed proprietary cloud data warehousing stack. But now, given today's data volumes, today's like diverse needs around multiple use cases that we have, they're finding themselves building like silo data platforms. They have to build, for example, a data lake for data science and still do something like Snowflake for BI. So this is kind of the pain that people like, goes back to when I said, this is my data, just leave it in my own account. And I can bring like a BI engine on top and a data science engine on top, and I can train machine learning models or do AI on it or do whatever I want with it. That is the biggest thing. So table formats is basically a layer that groups what is otherwise a collection of files shoved into like cloud storage into some meaningful table structure, right? It basically is what brings some structure to these collection of files and says, these set of files form a consistent snapshot of a table. This were produced by a single write and a single read. This may sound like super basic concepts, but this didn't exist, right? So we were just, even the 2010s and stuff, all we were doing was file processing. We would shove files into HDFS or Hadoop or on Ceph or on these distributed storages, cloud storage, and we would write jobs to crunch them. And if somebody try to write some files into that like table or data set, if you will, and it failed midway, you will see the partial write. Like there is like, so there is no kind of transactional kind of like primitives on it. And our story began at Uber, where we had a on-prem data warehouse and we had a file-based Hadoop cluster, if you will. And then, like I mentioned, one had scale. We could process a lot of data. We could store a lot of data. But the other had all the transactional features that we liked, right? To be able to do things in a more reliable way. So we thought of this Apache Hudi project as some kind of like a hybrid, where we said, what if we just like retained the scale and the compute, because you can scale compute horizontally, you can scale storage horizontally, just keep those benefits, but simply bring like some sort of like a database abstraction or like some transactional abstractions around how you read and write data or files on top of such storage. That is kind of like what is like, what today we call a lakehouse. Lakehouse refers to the overall system, if you will, the entire stack. Table format's kind of like a small component, or like, but an important component in that piece, where, like I mentioned, it just provides you those table abstractions. Then you can build a lot of these typical database services that are like reading and writing, and they're doing kind of query planning optimization. You can build the rest of the database stack around it. So that's generally what's going on. So it's a big unbundling and disaggregation of the your closed and tightly coupled data warehousing stack to accommodate new use cases. So I know, like, I probably went in 3 different directions there. So happy to
we do want to dive into kind of into more of this. But before, one comment I know Tim's going to follow up with is, we start off, right? Databases is all like tightly connected, right? The storage and compute is one place. And then what's interesting is that we can separate storage and compute, and we started doing that, but then it's separated, but it's still together, right? Because then you're like the Snowflake, all these things originally started saying, well, we're now in the cloud and you separate storage and compute, but only this compute with this storage can work together. So we separated, but it's still kind of connected. I think, but that needed to happen first. I think we evolve and realize that at the end of the day, it was tightly connected for a reason, right? You had all these transactions and stuff you can go do, and the moment you separate them, well, what happened to the transactions that you're doing, the whole asset stuff that you're doing? It's not there. So now I need to do that work. So I think we probably, I don't know, 2 steps forward, 1 step back, but that's how we started advancing around these things. So I really appreciate this, and we've gone into some very nerdy database stuff in here, but let's actually elevate a little bit back, Tim.
Yeah. Vinoth, I wanted to ask you a question here because, and I have a feeling our listeners are going to be very interested in this as well, just because they're trying to grapple with all the things that are going on in the space right now that you're talking about. I came from the Hadoop world, and I actually was, I used to work at a company called InfoChimps, which was one of the earlier companies doing Hadoop as a service back in, late 2008, 2009, that kind of time frame. And, it was very clear, like around, file formats and things like that. And as things went on, then, things like Parquet and Orc, right? It was like a lot around partitioning and around performance and things like that, right? So I kind of understand like that side of things, more of the file format side. But to be 100% frank, I'm not 100% following kind of the latest trends. Like, why is Iceberg becoming so popular now? And like, what's the difference between like a file format and like a table format? And why do I, care about having like an open standard around table formats? I was wondering, is it possible you can kind of explain in really layman's terms, like what's a table format versus like a file format for maybe the kind of the uninitiated?
That's a great question, and maybe like I'll start with that. And actually, a root of a lot of this confusion actually also ties to your question around like the buzz around like iceberg and why do you hear that like a lot more and stuff. So
Right.
that has been mostly tied to kind of this ongoing feud between like Snowflake and Databricks and how each one wants like whatever, right? So
Hmm.
let's not get too much into that. But if you look at what a table format actually does, now that you understand, let's start with this baseline, right? So we have a Parquet table, which is like on cloud storage. There's a bucket with some folders, and across these folders, the folders are the partitions, if you will, and you have like a bunch of Parquet files, right? So now, let's imagine.
Sorry to interrupt. Because this is I want this episode to really be kind of a demystifying and explanation.
Right.
Explain Parquet files.
Okay, awesome. All right. So everybody knows a CSV file, right? So it's essentially you have 100 records and you want to store them in a file. You basically write 100 records, 100 columns. You'll write 100 entries, 100 wide, right? So that's a row, like the simplest of the row-based file formats that you do. It's row-based because you're storing like line by line. So you're essentially encoding row by row, right? So this is there are far more advanced binary formats for row-based formats, obviously, which all let you, like SS table is a good one. We use one of them, like, if you're familiar with HBase, Cassandra, any of these like online systems, they're all based on some version of that. So essentially, it's really good for seeking one row at a time. So as you can imagine, this is great for online databases where you're asking, give me one record, like this, look up this user's age or whatever, right? So, but for analytical queries, you're like probably asking, okay, sum all the salaries of these employees in some like region, or you're asking for total amount of Uber rides that happened in the last 1 hour in the city or things like that. So you really need the ability to kind of scan and crunch data, right? You don't necessarily need like row by row access, right? So this is where columnar formats come in. So columnar is pretty simple. What you do is same 100 records, 100 columns. You first start writing column by column. So you'll write the first value of the first column, second value of the first column, blah, blah, blah. Then you'll start writing the second column and so forth. So what
It's
this
almost
gives
like
you,
almost turning it on its side, right?
exactly. It's like, so what you get is this is optimized for if you want to just, let's say you have 100 columns, right? Let's say our query is sum of a fare on trips where a city equal to something. So then you just need to scan 2 columns out of 100, which gives you like a lot of efficiency, right, in actually like answering that query. And this is like specialized for analytical formats. And Parquet is not the first columnar format by any stretch of imagination. There are lots of columnar formats that have been invented for many years, a couple of decades even before that. The C-Store paper, I think, started all of that. And there's like Dremel, there is like a lot of systems, right? So generally, Parquet is an open source implementation of this like Dremel paper from Google, which describes a way to encode nested and flat kind of schema into columnar file format. So once you have this, so if you look at in the additional details, as you're doing this, you get better compression because you are like packing the same kind of data with each other, right? So you can do a lot of things to store data in more compact forms, so which all saves you storage costs, compute costs, and all of that. And then you can also write statistics along with it. So for example, min and max, you can compute min and max for the data that you're writing. You can count the number of distinct values. So these are all things that then when you're actually answering a query, you can use to optimize that, right?
Yeah.
So by and large, there is like ORC and Parquet. Like this is generally the one thing with like open sources. Sometimes the bet, like the more deeper ones don't become public. It's really like how what vendor pushes what and that kind of thing. But like ORC has indexes and stuff. For example, Parquet has gotten those indexes in the recent years, I feel. So Parquet is like more prevalent because I would say mostly like Databricks push like Parquet a lot more along with Spark than ORC, things like that. But by and large, they're kind of equal in formats, right? So that should summarize what
That's a perfect
like.
Parquet. And by the way, just kind of putting my historical background. they're like separating like the row store and the column store. Like this isn't a new thing either from the 2000s. I think one of the very popular, I remember this in my database course, looking at the history, is look it up, decomposition storage model, right? I think that's one of the earliest one I know. That paper is from 1985, and probably it came out of here in Austin. So like this is stuff people have been working on from the beginning of databases. What are you thinking about this stuff, right? So,
got it.
Anyways, perfect. So we want to okay, file. Bring us back.
Yeah, well, I guess I was going to say the risks of having like a database TA on the call is quoting a paper before what I quoted. That's awesome. But all right, cool. Let's get back. So let's say we have these Parquet files, let's say, right? And then we let's assume we have a base table, right? And let's say in this case we are storing Uber trips, for example, like whatever, right? That's an example. So there's a bucket, and then there is folders under that. Each folder represents the day in which the trip happened, for example. That way when you're writing queries, you can say, if you just want to process 1 day's worth of trips, you just like scan that one folder's worth of data, right? But then within each folder you have Parquet files that are storing like all kinds of information about a trip, right? Let's say we have something like that. So now what are the operations that you want to do, and then let's try to derive why you need a table format and what it kind of does, right? So first thing, what you need to do is, let's say I want to change a trip, right? Let's say you took a Uber ride and then you were kind of like unhappy with the route or whatever, and then you wanted a refund or something, right? And then your fare changed basically. So now we need to go and update that record, right? So by that, what we've kind of pioneered 2 ways of doing this, which I'll keep it like very simple. But for now, the simplest way would be to write a new Parquet file with just that fare corrected, right? I mean, just the most simple way to do this. So you would change files, right? You need to change the values, and you may be doing this across multiple trips. So a writer could be kind of changing like a bunch of different files across these folders. And what you want is, you want the table state to go from the previous state to atomically reflecting all of these writes, right? So the reader, this is the first very basic thing a table format does. Is quite simply, if you look at something like Iceberg, what it does is it's the simplest thing that you can do, which is a file. You write a list of files in that file, and you say to figure out, and you give the snapshot a name or a UUID or whatever. So you basically say this set of files form a table, and then when you write again, you say this set of files form another table, right? You keep doing that. So obviously you're essentially publishing a snapshot of a table, and you're just like holding a list of files. So if you look at Delta or Hudi, like they approach it slightly differently. They both have a log. So it's like, there's some kind of like a checkpoint. And then you say, okay, I added files on top of the snapshot. I removed files from the snapshot. So then you derive the latest snapshot by kind of like compacting that log, right? So this is more for more frequent updates and stuff. As you can imagine, like that snapshot model can get like very slow pretty quickly. But all in all, when we do this, the other things that we do, remember when I talked about Parquet, I talked about statistics, right? So the other thing that cloud storage is really bad at is, listing, right? If you list a lot of folders with lots and like deeply nested folders or folders with lots of files, it's like slow. So we already solved that problem we keep one file with a list of files. So that solves that problem. But the second problem is the statistics that I was talking about for Parquet. Those are written typically in Parquet footers. So what you need to do to plan a query is to first read the statistics out of the footers. So let's say you have like hundreds of files. You need to make hundreds of get calls, like get is in cloud get calls to like read those stats. So the other convenient thing table formats that you do is simply write for every file, here is the statistic for that column, right? Again, similarly, if you look at different table formats or like storage, they do it differently. So Iceberg basically writes it along with that snapshot file. It basically stores, here is a list of files. For this file, this column has this min, max, blah. Again, same thing. If you imagine a 100,000 file table with 1,000 columns, you can do the math and look at like number of values you will store. Delta basically does it encodes it in another Parquet checkpoint file. So that metadata itself gets a little bit more compressed. We basically we were like Hudi, we were born at like some of the largest data lakes. So we actually have a separate table which is encoding and indexing this columnar data such that during query planning time, if you like going back to our example, if you have two columns that you're asking for, I only want to read those two column statistics, not everything, right? If you store it in a flat file, you have to read everything. So we store an indexed file. So, but by and large, they store a list of files that make up a table along with some statistics about those files. And this becomes now the beachhead for any query like planning execution to kind of, I can read this, I can read the snapshot. So the table can be like all of these provide snapshot isolation. So you can be writing to this in the background, but my query is running on a snapshot. You get time travel. You can implement time travel using this and say, I'm going to retain X snapshots, and you can query the table as of yesterday, like all of this, right? But that's what conceptually a table format provides you. But the actual design, the metadata design of how you lay out the metadata can give you either read optimized, right? Like for example, Iceberg is like very read optimized because it stores everything as a flat file, or you can be a little bit more write optimized and optimized for higher scale metadata if you expect the whatever. So those are the technical differences under the hood. But at a very high level, now you can now imagine what this unlocks, right? This unlocks now some like tables that can be shared across multiple engines, right? And if you look at the previous separation of storage and compute, it did solve a very key pain that we had at Uber, because we were using on-prem data warehouse, right? Architecturally, you cannot we cannot scale them independently. You have to like have the cluster be the max of compute or storage need, right? Whereas in something like Snowflake or BigQuery today, you can store as much data as possible. You can spin up different compute clusters to access the same data, right? It's the same model, but this now lets you do this across multiple engines. You can have Snowflake querying the table, as well as some Presto querying the table, as well as Spark querying the same table. And that's kind of the big shift, I would say, if you from the the proprietary data warehouse compute storage separation to this layer is become like a pretty strategic kind of battleground across like the cloud vendors also because of this, and that's explains the buzz.
Yeah, I mean, this is super interesting. I really appreciate you walking through that because it really unpacks the different pieces of this and how they kind of layer together, and honestly how it kind of mirrors in some ways kind of like the journey that we went on when I was like, oh, HDFS, well, let's layer Hive on top, right? And like needing to layer these kind of layers of abstraction and compute efficiency on top of the different formats we put in place. Vinoth, would you kind of say that, and let me test my knowledge here if I'm kind of understanding. So, these table formats, right? There are certain kind of approaches to this today. Like if, for example, if you're in the Databricks ecosystem, there's like the Delta Lake approach, right? Like these kind of table formats are enabling sort of more performant interaction with these sort of columnar files, and ideally, it's going to be doing it in a more interoperable way. And I think that's especially where you're coming from with Hudi and with the sort of the Onehouse kind of approach, right? Is like, hey, how do we make it so that you're not stuck in a particular stacks way of thinking of managing these files, and instead you have an approach which can follow you wherever you need to go?
Yeah, that's a great point actually. And we've done a bunch of work around this, which is like pulling back. Let's take the same example. And so when we started Onehouse, right, the one thing that we started running into more and more was, so we write using a table format, right, and which organizes the Parquet files in a certain way. And in our scenario for Hudi, we build indexes in front of the table, the data files in reality, because if you think about it, we have like billions of like data points, and if I have a fair update to one, how am I going to quickly figure out what file to go rewrite, right? So we need an indexing component. So that gives us like a lot of write speed, right? But now something like Delta Lake, let's say, does not have that. But Databricks is like a really awesome product where you can, have a very good Spark offering, right? Same thing for Snowflake. Snowflake's like a really good data warehousing engine. Like a lot of people like it for how easy it is to use that, right? So what we realized was, if you actually think about this, right, and I really love how you separated the table format, file format discussion. The file format is still Parquet, right? So what we kind of came up with was, well, it's actually not. We can actually, kind of be a win-win situation here, where people could be using these indexing or the picking like an optimized, like write format, if you will, and with a little bit of metadata translation, because we could also write, if you have a large table, this metadata is actually pretty small, right? So we could be writing metadata in like multiple table formats, if you will, all consistent with the same snapshot, and we could expose them as delta tables for Databricks and iceberg tables for Snowflake, right? So this actually, to me, realizes the promise of this architecture, because if you use this to again build like a proprietary thing, where like what Kwan was saying, it was separated, but it wasn't really separated, but you still built like a stack with affinity to particular storage formats and stuff. It kind of loses its whole point. We'd rather just be using the proprietary multiple stacks for that, right? So that's something that we released as one table initially, from Onehouse, because that's a feature that we built for ourselves and we kind of open sourced it. And then last year, Databricks came out with their own called Uniform. And now we donated one table into the Apache Software Foundation along with Google and Microsoft as Apache X table. And it has now like broad support from across the industry around interoperability of like, these table formats, if you will. And that's, I think, been a very exciting development in my view, because I don't think we've ever had a project that is focused on interoperability, right? We try to unify things on one thing every 5 years, and we like move from one thing to another. We move from Avro to Parquet, we move from like Hive to Impala, or Impala to Presto. That's generally what we've been doing. But this is like a very exciting effort where we've set like actually realize a system where we can have a single copy of data exposed as multiple table formats, if you will, and people are able to pick write and read formats. For example, the Snowflake and Microsoft announced a partnership where Snowflake can write iceberg tables and have be translated into Delta Lake tables for consumption in Fabric, which supports a lot more Delta Lake, right? So
I want to extract this a little bit and kind of go a little bit on a tangent and have you on honest, no BS. This should be a lightning round question, but it's probably you're gonna have a longer answer. So everything that you're saying, I'm thinking about people in data teams and organizations. How much do they really need to go and understand and go into all these details? Like what type of organization and what type of data teams need to be, what situation do they need to be in such that they need to really dive into the details that we're discussing today versus is like, that's too much. Like I just need to have something that's abstracted because I just need to get my dashboard for my boss to go work, right? That type of stuff. Like,
yeah, this is
point in a way, right?
Yeah, so this is like a loaded question, right? And there is like the first pivot, right, which is, do you build versus buy, right? Are you in the market to go buy or build using open source components? So one of the core reasons we started Onehouse was we see this bipolar disorder in the market where you either are like, okay, I'm going to go just like buy a proprietary solution. I really don't care whether the fundamentals of where the data is stored is in an open format. Can I get it out later or bring another engine? So there isn't like a lot of that thought going on early on. So we see that a lot of people rush into the data platform, the first two generations like that, and they either suffer from very high costs later on, or they don't know how to move, bring other use cases. For example, you're in Snowflake completely, and how do I now bring data science on top of this? That I've seen like a lot of people, when they try a data lake house or a table format, they are on the journey from, hey, I built my first data platform, which is a cloud data warehouse. Now I think I want like something a little bit more future proof and a little bit which can support, which is flexible for multiple use cases, right? That is the point at which people start to care about the open data lakehouse, right? Second point on this is these technical details around what format to pick and blah, all of these things, right? There I think there is general consensus, right? If you have some like mutable workloads, if you have CDC databases to ingest and things like that, we have like formats which are like something like Hudi is like a lot more used for those scenarios. If you have typical batch use cases, honestly, all three would work, and Iceberg probably maybe like a simpler choice in that model, right? But really this intra layer that I was talking about is actually designed to make that friction go away, right? You can pick anything, right? You can generally pick, so when you say pick, especially let's say you're building something, you're going to take a framework like Spark or Flink and then try to write into these table formats, if you will, right? If you're not happy with the performance or feature set or functionality, you can pick whichever one you like. You can make the choice even at the table level, but this intra layer is going to make sure that all of this data can be read in a consistent, uniform way by the engine. So this is like a problem, and then this is the intra layer is actually trying to address that issue, and we are trying to move. Like the spirit of your question was, this is like low level stuff. Why, like, is it too much for people to consider to build like a data platform, right? So yeah, I think we are moving in that direction. We are not quite there, but I think today you would still, I think, have to carefully consider your choices here.
Yeah, I mean, the way my interpretation of this is that, like, depends really on how much, like, what is your current use cases that you're focusing on, and then like what is your plan for growth of bringing in more use cases, and you really want to go future proof and stuff. Because if like you over focus what you're doing today with one particular vendor, then that stuff may come back and bite you in the butt later on because it's too expensive, whatever, for new use cases that you want to bring in. And then you're like, well, I need to go do this extra work to kind of make it work because that team needs to use this other technology or whatever for their reasons. And then you don't want to go back to our original starting point. Just leave my data where it is, right? Don't have to copy it all the time.
But honestly, I think today, I think there's a good amount of people who cross that bridge. But most people, I think the first message I would like to see is you're picking one of these at least, right? Well, like forget whichever you pick, you're at least picking one of these like open table format lakehouse things and kind of centering around them, because you have the interoperability projects, you have like a mature ecosystem around like them, and most vendors support all three of them. So you should at least start there, right? And that's a good starting point for folks, I think, as opposed to like, oh, this is all too complex, I'm going to go lock my data into like the vendor's cloud bucket.
That's actually excellent advice around that, and I appreciate that for our listeners. So we kind of started at the bottom kind of the stack. Like, let's go up a little bit, right? Let's unpack. We talked about, we wanted to unpack that stack all the way to now we hear about like meta stores and catalogs and all this stuff. Like, how do we get from there all the way to the top of the stack?
Oh, wow. Yeah. So that's the other interesting thing. So, and this kind of validates the advice that I just gave, right? Until we build the interoperability layer, for example, we were not talking about catalogs. Now that, because the end of the day, think about it this way. You have multiple writers, right? This whole vision is that you can have multiple engines write and read from the same shared, like a location on an S3, right? But there needs to be somebody, like needs to be a shared transaction manager for that, correct? Like there's somebody who has to sit across all these engines and do that. There is no such thing, right? Because so today, if you write a table, like an open table from Snowflake, like in, let's say, Parquet, Iceberg or something, only you have to go through Snowflake SQL layer to write it, manage it. You can read it from another engine, right? So you have like, you pick a writer, you can have the interop layer and everything gives you like universal reads across everything, right? So I think and the other thing is, if you look at these catalogs, they are actually lock-in points in plain sight. The only open operational catalog, that meta store that we have, and which kind of like, showing its age is Hive meta store, right? But everything else, if you look at it, the catalogs, like your entitlement, the permissions that you place on these tables, and all of those things are pretty much locked into either like a cloud operated data catalog or something owned by the data vendor. And I think there is now all this recent activity has been started from Unity catalog and Polaris from Snowflake. They're now like kind of restarting this discussion around like there needs to be an open meta store, right? But again, like I would love to, like you guys are like deep in the space, and the one thing I always feel is there's a different kinds of catalogs, right? This is not addressing every catalog problem that's there. And that's another thing, right? I love to see whether Unity evolves into the only catalog you need, or Polaris is tied to one particular table format. One out of the three formats is basically what it's tied to. Is I don't know if tying a table format to like a catalog is like a right technical kind of like thing to do. Like it shouldn't be that coupled. We are after all arguing for compute and storage to be decoupled. It's kind of weird to have like a catalog tied to like how you represent stats in some files on cloud storage, right? So there is like a lot of different things going on right now. So love to get deep into this with you all as well.
Well, I don't know, Tim, do you want to? I can go, or you can go.
I think I'll make an observation, and then I'm curious, Juan, if what your questions are, which is that I feel like there's two philosophies when it comes to cataloging and metadata, right? Like I think there's a little bit more of a less technical philosophy around catalogs, where it's almost more of like a marketplace experience, right? It's like, oh, we want to help the business users to like understand the definitions, and we want them to be able to be able to like find data products and know what the data contracts are around those data products. And it's a little bit more about like the broad democratization appeal, which feels more like a layer on top, right? But then I feel like there's a philosophy around catalogs and metadata layers that's much more tightly integrated and perhaps more technical. And that's where you hear folks saying things like, oh, I want my Parquet file formats and all my schemas and my serialization and my, I want all of it in the catalog, and I want to know exactly when it happened and what the version number is. And like, there's almost like these two angles, and they kind of intersect with each other. So I don't know. It's kind of, that's my initial thought, is like the two philosophies around catalog. And is there a right answer? I don't know. Maybe it just depends on the personas you're trying to serve, right?
And I was going to say, it depends on the personas, right? I think we need to have the metadata, like this is just explains to us what this is, and then it's being used by so many things, from the query engine optimizations, right, to anybody else putting things together. But the personas are going to be very much more technical, right? From like super technical data engineers probably are going to go need this type of stuff, versus even if you're still a technical, but a data scientist may not need to go into that type of stuff, or a data analyst is not. But and then goes up to like more of the high level business users want to be able to go create the marketplace and stuff. And what I find interesting in a way, I don't know if it's contradictory or actually it's kind of illuminating, maybe, is like we talk about these stacks, and in a way, like when you talk about a stack, it's like, well, stack 1 at the bottom talks to stack 2, and stack 2 talks to stack 3, and so forth. But does stack 5 go back, connect directly to stack 1? Well, not really. I mean, there's a reason why it's a stack. You have these layers of abstractions around these things. Yeah. So this goes back to, if you think about the catalog and the metadata, is there like one side stack that connects to each single layer over there? And if it does it go all the way down to the bottom, or maybe somewhere to the middle? So I think the other question is that you have some metadata stack that is kind of is part of the compiler between each of the stacks. So I mean, well, then obviously, if you say there's a one size fits all, like this is my catalog that does everything, well, guess what, right? You're never going to satisfy everybody's requirements, right? So I think this will always be somewhat of a moving target, and it really is going to depend on the personas or the tasks that you're trying to go solve. And I think it's going to come from the true bottoms up approach. So I think you think truly from the bottom of the stack, you're going to have like those metadata requirements go up. If you start from the top, You're gonna have requirements, and you go, and maybe you'll probably even start from the middle, all right, and do that. And I think we have like the whole meta stores, like the high meta stores, like those are really at the bottom. You think look at catalogs like us, did our own probably more at the top, and then you'll have things at the middle that maybe it's something like the Polaris and the Unity. So, what do you think? You asked us, we ranted here. Let's throw it back to you before we go to a lightning round.
Let's maybe do like the same exercise that we did for file formats and table formats on this, right? And so in my brain, at least, I compartmentalize them as operational catalogs and business catalogs. So operational catalogs just store the technical metadata, like they store these table schema, like Parquet structure. The consumer of those is basically the engines themselves, right? So I mean, let's face it, right? No engine's gonna read like a flat file with statistics and actually plan a query. That will take forever, right? So most of them have like their own specialized, high performance representations of their metadata that they cache in memory or backed by a NoSQL store or what have you. So these are things where the point I'm trying to make is these are things that will be like closely tied to the engine, right? This is stuff that Snowflake or BigQuery or Databricks will call on the query planning path to answer a query. So I think that is an operational catalog, and broadly it has table statistics, and you need like you can set permissions, right? You can be like access control policies at the row, column, like cell level, if you will, because again, these needs to be enforced by the engine, right? The engines need to like kind of say, oh, this query is trying to access this from this user. I'm not going to let you read this bit, right? So I think, to me, Polaris squarely falls in that like operational catalog. High meta store is an operational catalog, and I think where the thing, and then there is like business catalogs, right, where there is, you are actually tracking stuff across systems, because data does flow across systems, and you can have one operational catalog track like that lineage, and there are other entities, right? Data flow, right? You want to track models. There are tables aren't the only entities you want to track. There are other entities you want to track. So you always have a need for these like governance / like business catalogs just sitting on the side. And I like your point about maybe they can just talk to the operational catalogs and get what they want. Maybe they don't have to go to the Parquet layer and stuff, if you will.
Yeah.
Right. So maybe that's like the middle ground. But I think there are some catalogs which like straddle that line, right? Because you have an operational catalog slowly adding some of these like management features. But to me, you're still tied to those engines that support. Like, for example, if you take the AWS Glue data catalog, it probably has a little bit more, it has tags and like other features there as well, but it's still within that AWS ecosystem, right? So for example, if you now go out of that ecosystem into another engine like, Snowflake or something, Snowflake is not going to respect any of those, and you need to like reset. There's a different catalog inside that ecosystem to do that. So I think for me, if you're a large enterprise, you kind of need need both. You need like a business catalog that kind of can go across your systems, and you obviously need like the operational catalog to just like do your basic like stuff, right? The thing that I think I am realizing more and more is, even with like open formats and open table formats and all of this, if these, like, again, think about it, like there's not going to be a single operational catalog, right? Just like physics, right? Snowflake, BigQuery, Databricks, like all these 7-8 engines have to call a single microservice running somewhere to do query planning. That's not going to happen, right? So they're all going to run their own, like there's 7 engines, there are going to be 7 instances of operational catalogs. So there is always going to be a need to keep all these catalogs in sync, and kind of like, get your data, get your like enforcements and entitlements, like enforced in the right consistent way. So those are all, I think, are some interesting problems where maybe business catalogs can help, or maybe newer projects can come up and help. But to me, that is something that I see as a fundamental problem for people.
Yeah, that's a fantastic point. I would say so. Takeaway here is that operational catalogs right there. There's many of them, which is a problem. Keep it in sync. So that's something that needs to be addressed. I would argue that in your business catalog, you should probably only have one, And if you end up having multiple of them,
Yeah,
that's giving you pain. But hey, look, I knew that we got to wrap up soon. Like I knew there's so much more we're going to do, and I look forward to our next conference to hang out and meet up. But let's quickly go to some lightning round questions. So quick, yes, no, couple answers here. So first question. So which persona benefits the most from these open table formats? Is it the data engineer? Is it another persona?
I think it's data engineers. I think if you know how to write some of these like wrangle some of these like open source data processing frameworks, you can like do a lot of impact to your company by adopting all these.
Tim.
All right, second question. Will companies start with an open table format from the start, or do you think more often they're gonna feel some pain between like having multiple siloed systems and things like that, and they'll switch to an open table format?
So I think most small ones start with some sort of like a warehouse still. I think that's what's going on. I think once you hit even medium scale, we are seeing like, few 10 terabytes, let's say like 10, like total storage, you start to like seriously think about like an open table format and bringing multiple layers.
That's great. I love being very specific.
It's the scale of the data. Yeah.
All right. Next question. Do you see that most companies will consolidate on one data cloud, or are multiple data clouds going to be the norm?
Multiple data clouds. Even if not, they're truly doing multi-cloud. I think everybody wants optionality and the fact, they mix and match, especially large enterprises, to just even get like bargaining power with all three.
Yeah, that makes a lot of sense. All right, last question. This one's actually going to be an open-ended question. What's next for open data and open compute?
All right. So I think we talk a lot of open data, but end of the day, if you even look at the iceberg ecosystem, you have so many vendors talking like open washing themselves with open table formats, but they all have closed compute services, right? So end of the day, you can have open data, but if all the services that read and write from it are closed, your data is is still in jail, right? So I think the next big thing is unbundling this entire data platform with both managed and proprietary and open components, so that you can swap them in and out. For example, like in our platform, again, it's not a sales pitch, but like you can either do ingestion on your own and just by management, or you can just do all of it on open source, or you can do all of it in managed. So we need a world where you can swap managed services in and out, and you should be able to pick and choose what components you want to build in-house using an open source project, or buy something, right? So that is the big next step. So compute lock-in is as severe as data lock-in. It doesn't get enough mind share, and I think we're going to do a lot of things next year to address that. And forward to that.
Well stated.
Well, so much, and we're going to do our best. This is going to be a challenging takeaway. Tim, take us away.
Oh my goodness. I'll do the best I can here. So we kind of started with like honest no BS. What's all the buzz about like open table formats and things like that, right? So you started off by saying that, companies are saying, okay, it's my data. I want to leave it alone in my cloud storage bucket, and I want to move to sort of these new cool query engines. And, we started to kind of go into a bit of a history lesson around how originally, storage was tied to relational database management systems. And you really only had kind of two types. You had your transactional, your OLTP, and you had your more analytical oriented databases, your OLAPs, or, more commonly known as your data warehouses, right? And there were really like 3 decades of this. But then we hit kind of the next generation kind of web scale companies, where we had recommendation systems, social networks, et cetera. And that's where we really started to see some separation of storage and compute. And we saw really a new set of possibilities come to life, right? So, cloud data warehouses kind of became this new option. And, we went through the Hadoop phase and things like that. And what we found is that being able to have flexibility around file formats, being able to have flexibility around our compute engines, that this created a lot of power. We can really squeeze out more performance, and we can optimize kind of the right use cases for the right engines. Kind of fast forward to, the last 10 years, right? Table formats became a really important way for us to be able to group these files, these things like Parquet, for example, into really meaningful table structures, and be able to get good performance out of it. And later we talked a lot about sort of interoperability as well. So it's clear that as the data stack has been evolving, right, these different pieces around this sort of, more flexible data system, right? That's not just about kind of row-based data. It's column-based data. It's semi-structured data. It's unstructured data, needs to have this kind of technical flexibility. And you did a great job, Vinoth, really going into and unpacking this for our listeners around, like, what is Parquet? What is, a table format? Why is this valuable, right? And you even mentioned with Onehouse how, the file format might be Parquet, but, people want to be able to really have write optimization in some cases, or read optimization in other cases, use different compute environments. And this is a way to have a lot of flexibility and power around that. So I think for those that are listening, check out the main episode here. If you're just listening to the takeaways, and you can learn and hear how Vinoth walked through all of that. But Juan, what about you? What were your big takeaways?
To continue on, like, we had this discussion, like, well, do we really need to know all these details? Like, it seems so very technical, and kind of goes a lot in the whole build versus buy situation, right? If you're in a buy system, right, you get something, then you may suffer those high costs later on, especially if you start with one use case and then you want to bring in some other use cases that need some different kind of requirements, so that's going to be effective. And I think this is where these open formats and these open data lakehouses come in, because that's the future proofing. So even as we said in our lightning round, discuss that, like, for starters, you will be picking these open formats around there eventually. And I think, like, even at that 10 terabyte level, you said it's a good tipping point. And I like how we just ended up the discussion going up the stack, right? We have multiple writers with the universal reads, right? But that means like, oh yeah, you're going to write through Snowflake SQL, but anybody can read. But this is where, like, catalogs and the metadata stores come in. We had this great discussion of, like, operational catalog versus business catalogs. The operational catalogs about the table formats, the Parquet structures, things like the Polaris, the Hive, the Metastores. And right now there's several of these, and these need to be kept in sync, which is going to be an issue. It is an issue, things that will be addressed. But then you go up the stack, and you still need to keep track of all that metadata. That's kind of where the business catalogs come in, doing the discovery, the access control, keeping track of things across the system when you have the governance. I think we all agree that you should have just one business catalog. If you have more, then you have an issue right there. So, and as large enterprises, you're going to have both of these types of things. So, how did we do summarizing here?
Pretty good.
All right. Well, to wrap it up, let's throw it back to you. 3 questions. What's your advice? Who should we invite next? And then what resources do you follow?
All right. My advice on this topic, again, is like start open. It can't hurt, because all the engines on the market can read all of these, like, open table formats. So start there. And who should we invite next? I would love to hear from somebody deep building data infrastructure in the AI wave. So I'll let you guys go hunt for this person, but I would totally tune into an episode where they're talking about how that is changing how this data architecture yet again, right? So that'll be something that I would love to learn. And resources, well, single founder in a large company, don't get too much time, but I do the usual. I read data engineering weekly, so I read that to catch up on that, and I read a lot of technical blogs around the data lakehouse space, what's new coming in that. And I pick up a book from here and there when I have time, and mostly around business, because that's the part that I don't know as a founder. So I'm being the fox reading to be the hedgehog in that space. So yeah, that's kind of summarizes my learning activity right now.
All right.
That's awesome.
Thank you so much. Really appreciate you helping us dive into these details, because look, honest, no BS. A lot of people need to go, us included, to kind of go into these details. Thank you so much. As always, thanks Data World, who lets us do this every week. And with that, cheers. Thank you.